Okay, in this video, we're going to look at key features of quadratics and their graphs using completed square form. Okay, I just want to very quickly identify some key features on these graphs. So you see two different graphs. They should really both have arrows here to indicate that they're just going to keep on going forever. But this one opens up and this one opens down, and that's going to be dependent on A, which you're going to see when we do the first example. But some things we need to know. This and this, they lie on our x-axis, so these are x-intercepts, and we're going to be able to find those, okay? But these are x-intercepts on our graph. And so over here, even though it opens down, I still have, in this case, two x-intercepts. Sometimes you have one x-intercept, sometimes you have none, but in this case for both graphs we have two. And then this lies on our y-axis, and so this is a y-intercept. And this is our y-intercept. Okay, and then this point is our vertex. It's called our vertex of our parabola. But in this case, you can see that this is also a vertex, but they're different because this one is the low point on my graph. So we're going to call this one a minimum. That's our vertex in this case is a minimum. And our vertex over here, because it's a high point, is a maximum. Now, this can also be called a turning point. So if you see that wording, it's just asking for the vertex. Our turning point is because this graph was decreasing and then it was increasing. And this is the point where it changed from decreasing to increasing. And then over here, it's a turning point as well because it was increasing and then it changed to decreasing. And that's the point where it changed. The other thing it can be called is a stationary point. Okay, and in both cases, it can be called a stationary point. Because I was decreasing, at this point I'm stationary. I'm not actually decreasing or increasing where I'm turning around. And so in this case, I'm increasing. And so these are stationary points as well. Okay, and one other thing we have is we have what's called an axis of symmetry that you don't see when you graph things, but it is a line that goes directly down the middle, exactly the middle of each graph, where I could actually fold this on this line and these two sides would match up. And notice that like this point over here is the same distance as this point from our axis of symmetry. So our axis of symmetry cuts it exactly in half and goes through our vertex. Okay, so now we're going to look at identifying these things. Okay, two other things we need to talk about are domain. Now, remember that domain, when you learn domain, it's the x values. It's the possible x values on your graph or in your equation. In this case, this is our x-axis. And you see that this is going to go on forever, but it's just going to get wider and wider and wider. And so all x values in this case are positive. So our domain for quadratics, unless we specifically restrict it, is all real numbers. And this is the symbol for that. But you could also write all real numbers. Our range, however, is the possible y values based on our x values. And so in this case, you can see that our y values, so when we're looking up and down, we're looking at our y-axis, this is the lowest y value. All the rest of the y values are going to be higher than that. So in this case, we would say our range is y is greater than or equal to, and we're going to use the y value of the vertex, which we'll talk about, okay? But for this one, because it opens down, and you can see that this is a high point, and all my other points lie below that point, we would say the range is less than or equal to the y value of my vertex. Okay, so that's important to make sure you understand all of that. Now let's look at doing it with an equation. Now, let's look at what if we have completed square form? What if we've been asked to write it in completed square form? That's the form you see here. And so I can determine a lot of information from this form. So if a is less than 0, if this number out front is less than 0 or negative, that's what that means, then my graph is actually going to open down, which would look like this. And so that tells me that this is going to be a maximum on my vertex, okay? But if a is greater than 0, if a is positive, my graph opens up. And so it's going to look like this, and you can see that I'm going to have a minimum. So A is going to give me a little bit of information on that. Okay, now I also need to be able to identify my vertex. My vertex is always going to be H, K. Okay, so what I want you to see though is that from here to here, so this comes down, but it's an opposite sign. The inside of my parentheses here, whatever this is the vertex is going to have an opposite sign for my x value. So if this is negative, this one's positive, and if this is plus here, then this one's negative. But the k value, which is the y value of my vertex, is the same. It doesn't change, only this one. Once you've identified your vertex, you can identify the axis of symmetry, which is always going to be x equals, because we have to write it as the equation of a line, so it's always going to be x equals whatever h was. This value right here. That goes straight there. Okay, now for my range. Remember, my range is either going to be y is greater than or equal to, or y is less than or equal to. And how do we determine which one it is? Well, first of all, it's always going to be the k value. It's always going to be this y value of my vertex for my range. But it's going to be greater than or equal to if my graph opens up, which remember means that a was greater than 0. And it's going to be less than or equal to if my graph opens down, where a was less than 0. So it's important to understand that. And then I'm going to be asked for a maximum or a minimum value. Okay, you have to determine if it was a maximum. It's a maximum if my graph looks like this, and it's a minimum if my graph looks like this. So you have to be able to identify which it is. But the value is always going to be the k value, or the y value of my vertex, and it's going to occur at the x value of my vertex. So the y value is the actual maximum value or minimum value, but we can say that it occurs at the x value. And then the domain for all quadratics, unless we specifically restrict the domain, is all real numbers. Okay? All right, couple more things. The y-intercept, that would look like this. We would write it as 0, y. So the y-intercept occurs on the y-axis and has a 0 value for x. So to find a y-intercept, we are going to plug 0 into x and solve for y. For x-intercepts, we're going to have an x value, but y is 0 because it occurs on my x-axis. And so to find those, we're going to plug 0 into y and then solve for x. Okay, so this stuff you need to know really, really well. So let's look at some examples. Okay, in this example, we're asked to write each of the following in this form. So we're asked to write it in completed square form and to state the vertex, the axis of symmetry, the max-min value, the domain, and range, and then to sketch a quick graph. So we should know how to complete the square. I'm going to do it one time, but if you need to go back and review that video, you can do that. So when we complete the square, we're going to bring this 2 out front. And we're going to divide everything by 2. So I'm going to have x squared minus 2x minus 3. And then what we're going to do is, remember, we're going to take half of this. So negative 2 divided by 2 is negative 1. So inside here, I'm going to have x minus 1 squared, and then I'm going to immediately subtract that same value squared and bring down my minus 3. So I have inside x minus 1 squared, and then this is going to end up being negative 1 minus 3, which is negative 4. And finally, this 2 goes here and here. So 2 times x minus 1 squared, and then 2 times negative 4 is negative 8. So this is my completed square form, and we've already learned how to do that. So if you need to go back and review, please do so. Okay, from here we can get lots of information. So looking at this, my vertex, remember that this sign is opposite, so it's going to be positive 1, but this sign stays the same as negative 8. My axis of symmetry is always going to be x equals whatever that x value is right there, so x equals 1. Now, for my max minimum value, I need to look at this a, and I can actually look at a here, or I can look at this positive 2 in front. And since a is greater than 0, a is positive, I know that my graph is going to open up. So what I can say is that I'm going to have a minimum I'm going to have a minimum. I need to be able to identify it as a minimum. But the minimum value is going to be the -8. That's the lowest value on my graph. And it occurs at x equals 1. So understanding that is important. The minimum value is -8. It occurs at 1. So the vertex is a minimum location. Okay? And domain we should know because the domain for all quadratics is all real numbers. And then the range. For the range, it's always going to be y, and it's going to be the y value of my vertex. I just have to identify, is it greater than or equal to or less than or equal to? And that's based on this. So if a is greater than 0 and I know my graph opens up, I know that my range is going to be greater than or equal to. Okay, so for this sketch a graph part, our graphs are going to get better in just a few minutes when we talk about x and y intercepts. But in this case, I know that I have a vertex that's at 1, -8, which would be somewhere right around here. So that's the quadrant that I'm in. And I do know that I have an axis of symmetry and that my graph opens up. So just a rough idea, that's what it's going to look like. It's going to get a little bit better soon. Okay, I know that was a lot of information, but I want you to take a minute and pause the video and try this problem, and you can follow the steps from the previous one, and then come back and check your answer with me. Okay, so on this one, you should have written it in completed square form, and when you do that, you should get -3 times the quantity x plus 2 squared minus 6. So that's completed square form. And from that, you can identify all of this information. So you can have the vertex. Remember that this is a +2, so I'm going to have -2, -6. The axis of symmetry is going to be x equals whatever this value is. So x equals -2. In this case, you need to look at a. You can look here or here. A is less than 0, A is negative, so my graph opens down, which means I have a maximum. And I have a maximum of my y value, which is -6, but it occurs at x equals -2, okay? And my domain is always going to be all real numbers for quadratics unless we restrict it. And the range, in this case, is y, and we're always going to use the y value. But if you see this, because it opens down, I have a maximum, which means all the points are below it. So I'm going to have y is less than or equal to -6. Okay? Rough sketch. Basically, I have a vertex at -2, -6, so it's somewhere over here. But my graph opens down. So I do have an axis of symmetry down here, so I need to kind of make it the same width. But it's basically going to look like that. Okay? Okay, take another minute, pause the video, and try this one. All right, so y equals, again, we're doing completed square form, which you should know how to do. And when you do that, you get 4 times x minus 3/2 all squared minus 9. So that's my completed square form. The vertex is 3/2 opposite sign, -9. This one is the same sign. We have an axis of symmetry, always at x equals the x value. In this case, a is greater than 0, so my graph is going to open up, which means I have a minimum. And I have a minimum of my y value at my x value. Again, domain is all real numbers, but the range is going to be y. It's going to have my y value. But look at your picture here. Since this opens up, we're going to go greater than or equal to because all the values are higher than that. Okay, and again, for the graph, when we find x and y intercepts, it's going to get much better. But I have a vertex at 3/2, which is like 1.5. So I have that and then -9. I do have an axis of symmetry and it opens up. So roughly, it looks something like this. Okay, go ahead and take a minute and do one more of these. All right, so again, you're going to write it in completed square first, which is going to look like this. You're going to have -6, x plus 1 squared plus 7. Okay, from there, you should have identified the vertex to be -1, +7. So opposite sign, same sign. And then your axis of symmetry is going to be x equals -1. in this case, a is less than 0, so a is negative, which means your graph opens down. So we have a maximum of 7, our y value, at our x value. And then, of course, the domain is all real numbers. And the range, you're going to have y. You're going to have your y value. And you need to look at this. It opens down, so it's going to be less than or equal to. And again, since it asked us to sketch a graph, we have -1, +7. So that's my vertex. And I have an axis of symmetry. And in this case, it opens down. So it would look roughly like this. It'd cross somewhere, and we'll find those x and y intercepts in just a minute. Okay, so let's talk about finding x and y intercepts. Finding y intercepts, in this case, are really easy. I can actually use this form, okay? And I want to plug 0 into x, remember? So that would look like this. And y equals 0 squared is 0, 2 times 0 is 0, so I just get left with -8. So if it's in this form and you need to find the y-intercept, it's my constant value. It's the one without x. And we would write that as 0, -8, because we plugged x into 0 and we got -8. That's my y-intercept. But to find x-intercepts, now, you could factor this or use quadratic formula and find x-intercepts. But since we're going to have completed square form anyway, let's look at how we do that with completed square form. So if I take this and I write it in completed square form, I'm going to have y equals x plus 1 squared minus 9. And remember, to find x-intercepts, I need to plug 0 in for y and then solve for x. So looking at this, let's think about what we would do to solve for x. I would need to move this 9 first. I would need to add the 9. So I get 9 equals, and I have x plus 1 squared. And then in order to get rid of the square, we need to square root both sides. But when we do that, we have to put plus or minus. And the square root of 9 is 3. So plus or minus 3 equals, this square root cancels this square out, and I get x plus 1. So I need to move my 1 over. So I have plus or minus 3 minus 1 equals x. And this just means I need to do this twice. I need to do +3 minus 1, and I need to do -3 minus 1. So +3 minus 1 is 2, and -3 minus 1 is -4. So those are my x-intercepts, but we're going to write those as 2, 0, because we plugged 0 in for y, and -4, 0, because we plugged 0 in for y, and these were the two x values. So I want you to write x and y intercepts as coordinates. Okay, let's try one more of those. Go ahead and take a minute, pause the video, and find your x and y intercepts, and then check your answer with me. Okay, so y-intercepts, remember, are really easy. To find my y-intercept, I can plug 0 into x. And this is going to be 0, and this is going to be 0, so I'm just going to get 10, which you can see right here very easily. And so we're going to write that as 0, 10 as a coordinate. We plugged 0 into x and we got 10. But for our x-intercepts, again, you can always factor or use quadratic formula, but for these problems, you're going to have this written in completed square form anyway. And for this one, completed square form looks like this. So I want to be able to find the x-intercepts from a form I already have. Now I'm going to plug in 0 over here, because for x-intercepts we plug in 0 to y. And then I'm going to start moving things. You got to be careful. You have to move this 18 first. So we're going to subtract it. And then I'm going to divide by -2 to get that out front, or from out front. And so -18 divided by -2 is 9. And I have x minus 2 squared, and then we're going to square root both sides, but remember to put plus or minus. So the square root of 9 again is 3, so I have plus or minus 3 equals x minus 2. Then I need to add this 2 over here. So what I have is +3 plus 2, and -3 plus 2. So this is going to give me 5. And this is going to give me -1, which we're going to write as 5, 0. Remember, y was 0 for an x-intercept, and -1, 0. Okay, so on this example, I want you to take everything we've learned and we're going to put it together. So you need to write this in completed square form and then find the vertex, the axis of symmetry, the x-intercept, the y-intercept, the maximum min value, domain, and range, and then sketch a graph, because now you're going to have the x and y intercepts, so your graph's going to look a little bit better. Okay? Okay, so when you write this in completed square form, you should have -3 out to the front. You're going to have x plus 1 squared plus 12. Okay, vertex, -112. Opposite signs here, same sign here. Axis of symmetry is going to be x equals -1. Let's say a is less than 0. So my graph is going to open down. So I'm going to have a maximum of 12 at x equals -1. And I'm going to have a domain like normal of all real numbers and a range of y. I'm going to use my y value and I'm going to look at this. This opens down. Everything is below the vertex, so I'm going to have less than or equal to. Now, for my y-intercept, I can look at this, and I know it's going to be 9, and I get that by plugging in 0 for both x's from that form. So I'm going to have, this is going to be 0, and this is going to be 0, so we're going to be left with y equals 9. So we're going to write that as 0, 9. That's a coordinate. To find my x-intercept, I'm going to take my completed square form, which we have right here, and I'm going to plug 0 into y. And then remember, I'm going to move this 12 first, so I'm going to subtract, and I get -12 equals -3 times x plus 1 squared, and then I have to divide by this -3. So I get 4 equals x plus 1 squared. And then we're going to square root, but we're going to put plus or minus. So this is going to be plus or minus 2 equals x plus 1. And so what I'm going to have is I'm going to move this 1, and I'm going to have 2 minus 1, and I'm going to have -2 minus 1. So we're going to get 1 and -3. But remember to write those as coordinates. This is going to be 1, 0, because y was 0, and -3, 0. Okay, let's do a rough sketch. So let's look at our vertex first. I have -112. So let's just say -112 is going to be up here, okay? And if I had graph paper, and I would do this a little bit better. So when you do your homework, make your graphs a little bit nicer. But -112 is up here. I'm actually going to have a y-intercept of 0, 9. So let's just say that's going to be maybe right about there, okay? And I have an x-intercept of 1, 0. So I'd go out to 1 and I have 0. And I'm going to have an x-intercept of -3, 0, which would be somewhere over here. So not great, but there you go. Okay. And that's enough information. I do have an axis of symmetry, which you can see this distance and this distance is the same. I'm going to have my vertex here. It's going to go through this y and through that x-intercept and through that x-intercept. And that's a pretty decent graph now that we have x and y intercepts. Okay, so I know that was a lot of information, but go back and review what you need to, and we'll continue working in class.